Welcome to this explainer. So, here's a crazy thought. Water is basically a universal solvent. It's constantly hungry to dissolve whatever it touches. If you're a saltwater aquarium hobbyist, someone doing lab-style preparations, or even a vehicle detailer, this means your water quality isn't just important, it is literally everything. In this explainer, we're diving into a comprehensive setup guide to learn exactly how to get consistently clean water for your most sensitive projects. We're going to break down the science, the hardware, and the exact steps you need to take absolute control of your water chemistry.
Today, we're covering 5 key areas. First, the invisible water problem. Second, how RO/DI actually works. Third, the key components you need. Fourth, safe and simple installation. And finally, maintenance and performance tracking.
All right, think about the water flowing right out of your kitchen tap. We just naturally assume it's pure and ready to go, right? Well, for those specialized applications we just talked about, like keeping a delicate reef tank thriving or getting a totally spot-free vehicle detail, that tap water is often an invisible, highly reactive soup of problems. I mean, what looks crystal clear to the naked eye is actually packed with hidden variables.
Which brings us right into Section 1, the invisible water problem and the hidden dangers in your tap.
So here's the thing. Even the cleanest-looking tap water carries a hidden payload of dissolved minerals, and it varies wildly. What comes out of the faucet in your city can have a totally different chemical makeup than the water just a couple towns over. Relying on it directly introduces this massive element of unpredictability. And honestly, that's exactly how you end up with a crashed reef tank or a totally ruined experiment.
And you know those invisible minerals? They have very real, visible consequences. Just picture the inside of a pipe completely choked with scale. That same scale builds up on heating elements, actively messes with soaps and detergents, and leaves behind these really frustrating residues. Oh, and for scientific or aquatic setups, it's even worse. They cause major measurement drift in tightly controlled applications. You literally can't establish a reliable baseline when your primary ingredient, the water itself, is constantly shifting on you.
Let's jump over to Section 2, how RO/DI actually works, exploring the journey of a water drop.
Okay, so these systems usually combine 2 distinct stages. The first major step is reverse osmosis, or RO. Think of this as the heavy lifter of the whole operation. It uses shear pressure to overcome natural osmotic pressure, physically forcing water through the semi-permeable membrane. As the water pushes its way through, that membrane effectively blocks out the vast majority of dissolved solids. Things like salts and a whole host of other contaminants. And right after that heavy lifting comes deionization, or DI. This stage is the ultimate polisher. The water passes through specific resin beds that actively grab onto those stubborn leftover ions and exchange them for pure hydrogen and hydroxyl. It is literally building pure H2O right there on the spot. It's this exact 1-2 punch that takes your water from just filtered to truly purified.
So when we look at standard tap water versus RO/DI water side by side, the difference is night and day. Standard tap water leaves scale and causes measurement drift. But with RO/DI, your goal is pure predictability. You get water that is exceptionally low in dissolved solids, completely consistent day to day, and perfectly primed to protect super sensitive materials. Plus, it significantly drops your maintenance burdens. No more constantly descaling your equipment.
Moving right along to Section 3, the key components you need when building your system.
To set up this sequential defense line against contaminants, you're going to need a few core components. First up is your pre-filtration, usually sediment and carbon filters. Then, the RO membrane itself. Next are your DI cartridges, which really need to be sized to your expected water chemistry. You'll also need a flow restrictor and, crucially, TDS monitoring. That stands for total dissolved solids. You want these monitors placed right before and after the DI stage so you always know exactly what's happening under the hood. Oh, and most setups also use check valves to maintain pressure and stop any backflow.
But listen, the whole system absolutely depends on its very first line of defense. Pre-treatment isn't just some optional upgrade, it's protecting the heart of your setup. If your local tap water has a lot of chlorine or chloramines, those pre-filters are non-negotiable. Why? Because chlorine will literally oxidize and burn microscopic holes right through a thin film RO membrane, destroying it super fast. Without solid pre-filtration, your expensive RO membrane doesn't stand a chance.
Let's get into Section 4, safe and simple installation. This is basically your setup playbook.
Okay, by following these 4 straightforward steps, you can turn what seems like a daunting plumbing task into a totally manageable weekend project. First, gather your baseline info. What's in your source water? Is there chlorine? What's your starting TDS number? Step 2, plan your placement. Find a spot where you can easily manage tubing, swap out cartridges, and absolutely avoid freezing temperatures. Step 3, install the stages in the correct order. Pre-filters, then RO, then DI, and always connect to a cold water line. Finally, Step 4, once it's assembled, rigorously flush the whole system according to the manufacturer's manual.
A really critical detail here is flow management and safety. Like I mentioned, connecting to a cold water line with a shutoff valve is a must. You also have to use the recommended flow direction and tubing sizes so you don't end up with leaks. And remember, the RO process naturally creates a waste stream, known as reject water. You've got to make sure this reject water has a dedicated, secure drain, like a sink or a dedicated line, and that the whole setup is fully compliant with your local plumbing codes.
And that brings us to our final part, Section 5, Maintenance and Performance Tracking, or how to keep it pure.
0. This is the absolute magic number. After your water passes through that final DI stage, the ultimate metric you want to see on your total dissolved solids monitor is a massive drop down to 0. Your RO output TDS will drop a lot on its own, sure, but once that fresh DI resin polishes it, it should hit rock bottom if everything is running correctly.
Now, because every single location is different, you absolutely cannot rely on some generic, calendar-based timeline to know when your DI resin is spent. A filter that lasts 6 months in one house might literally only last 6 weeks in another. It entirely depends on your starting water chemistry and the sheer volume of water you're pushing through the system.
And honestly, this is exactly why tracking is everything. By sticking to a really simple routine of logging your TDS measurements at the RO output and again after the DI stage, you completely eliminate the guesswork. Keep a log, physical or digital, it doesn't matter. Just replace your cartridges on a schedule driven by your actual measurements, not a hunch. That's how you make sure you never accidentally use exhausted DI resin, keeping that perfect consistency you originally paid for.
ROD systems have this incredible potential to deliver consistently pure water, but they're really only as effective as your pre-filtration, your proper installation, and your maintenance. So, taking a look at your own specialized setup, ask yourself, are you still relying on guesswork, or is it finally time to take control and measure your water's true purity once and for all?